Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Rhyming Slang by Michael Lefkowitz. Sorry, apologies for that. Here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, or actually, I think I prefer the repeat now for this explanation. Okay. Normal Sudoku rules. Place a single digit in every cell from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. Digits may not repeat on apples, so therefore you can't have repeats on apples either, and digits may not repeat on the stairs. Why is this rhyming slang? I don't know. I'm not sure. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, we have a lot of digits in these normal Sudokus now. So where should we start? Sevens, not that many sevens. 2, 6, 8. We have all the odd digits. Okay, so maybe we should color them. Do we really need to? Not really. This is 1, 3, 5, 7, 9 in the row 9. So we can do that. So we have 1, 3, 5, 7, 9. Obviously, this can't be 3 or 7 because of 3 or 7 in the box. This can't be 7 because of 7 in the column. And no 5s because of 5 in the box. This can't be 7 because of 7 in the column. No 1 because of 1 in the column. Yeah, that wasn't too helpful. What about here? We have 1, 2, 3, 6, 8, 6, and 9. Okay, no 2 or 6, no 2. These are just digits in the row or column or box. No 3 or 6. No 3 or 6. Okay. Hmm. Let's see. Hmm. Hmm. Oh, interesting. Where can 6 be in the apples? Because again, we have, I think, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, we have 9 apples, and you can't have repeats, so 6 has to appear once. Cannot appear here, can't appear here or here. So 6 in this lower left-hand box must be in one of the apples, because we are missing a 6 from the apples otherwise. So where's 6 on the stairs? Well, 6 can't be here because it's on the apples. 6 can't be here because of 6 in the box. 6 can't be here or here because of 6 in the column or row. So that leaves a 6 on the stairs here. Which means this cannot be 6 anymore here. Which means where's 6 in column 6? It must be here. So this is 6. That was interesting. 6 in row 2 has to be one of these two because it can't be here because of 6 is in the box. 6 can't be here. 6 is one of these two in this in row 6. 6 is here, so 6 has to be one of these three. That's not that helpful. Okay. Are there any other ones that can match? Well, what about 4? That's not helpful. What about... Hmm. Hmm. 5 is here. Oh. 5 is here, and 5 is here in columns 9 and 8. Where is the 5 in column 7? Can't be here because of 5 in the box. Can't be here because of 5 in the box. Can't be here because of 5 in the row. So 5 must be here, and it is in one of the apples in this right central box. So that eliminates 5 from the rest of the apples. So this cannot be 5. We can't have 5 here. We can't have 5 here because it's in an apple. So 5 has to be here, which means this can't be 5 here. So that leaves 5 as being there. Where is 5 in this upper central box? Cannot be here because of 5 in the row. Can't be in the apple because we can't have repeats, so it's one of these two cells. Which means in this lower central box, 5 cannot be here because of one of these must be 5. Can't be here. Can't be in the apple, can't be in this cell because of 5 in the row, so it has to be here. Where is 5 along the stairs? Can't be here because of 5's in the boxes, can't be here or here because of 5's in the row, so it has to be here. So this cannot be 5 here. Okay. Where is 7 on the stairs? It cannot be here because of 7 in the box. Can't be here because of 7 in the column. Can't be here because of 7 in the row. Can't be here because of 7 in the row, so it has to be here. So that's 7. That means, where is a 7 in row 9? This can't be 7 anymore. And this can't be 7 because of 7 in the column. These can't be 7 because 7's in the boxes, so that leaves this as a 7. Okay. Where is 7 in column 8 then? Can't be here because of 7 in the box, can't be here because of 7 in the box, can't be here because of 7 in the row, so it has to be here. Okay. That means one of these is 7, and one of these is 7 here. Okay, where else are we looking? We have the stairs. 4 cannot be here, or here, or here. So where is 4 on the stairs? It must be one of these two cells. Because it can't be here, because of 4 in the row and column. What can this digit be, actually? We can't have 1, 2, 3, 4, 5, 6, or 7. So this is 8 or 9 here. Do we have something similar here? We can't be 1, 4, 6, 3, 7, 5, or 2. So we do have an 8, 9 pair here. Because 2 in the box, 1, 4, 6 in the column, 3, 5, 7 in the row. So we have an 8, 9, 8, 9 pair on the stairs, which eliminates 8 and 9 in the rest of the stairs. So this can't be 9 here, it's 1 or 2. We have 1, 2, 3, 4 remaining on the stairs. But this can't be 3 or 4. So now we have a 1, 2 pair on the stairs, which eliminates 1 and 2 on the rest of the stairs. This can't be 1 or 2. This can't be 1 or 2. So we have a 3, 4 pair there. And it also eliminates 1 and 2 in the rest of the box, so this can't be 1 or 2 here. So that's 3 or 9. Okay. Where is 3 in row 6? Can't be here because of 3 in the box. Can't be here because of the 3 in the column. So it has to be one of these two. In row 5, it has to be one of those 3. Where is 2 on apples? Interesting. Cannot be either of these. Can't be any of these. Can't be here because of 2 in the column. And it can't be here because 2 in the box. Can't be here because of 2 in the row. Can't be here because of 2 in the column. Can't be here because of 2 in the box. So it has to be one of these two. That's interesting. So that means we are guaranteed a 2 in one of the apples in row 4 and 6. We are also guaranteed a 2 on the stairs in row 4 and 6. That means we cannot have a 2 remaining in the rest of rows 4 and 6. Huh. Okay, we can't do very much about that right now, so that's not too helpful. Where can 4 be on apples? 4 cannot be on any of these because of 4 in the row. Can't be here because of 4 in the box. Can't be here because of 4 in the row. Can't be here because of 4 in the column. Or 4 in the box, sorry. So therefore it must be one of these two, which makes this a 4-6 pair. So this is a 4-6 pair, which eliminates 4 and 6 in the rest of the box. Where is 1 then in this box? This 1 eliminates those as possibilities, and the 4-6 pair on the apples, which they have to be on the apples because they can't be here, can't be here, can't be here, can't be here, means this has to be 1 here. And then this is 3, 8, or 9, which means we have a 3, 8, 9 triplet in column 2, which eliminates 3, 8, 9 in the rest of the column. So that leaves the remaining digits in column 2 as 2, 5, and 7. So we have 7, 5, 2. This can't be 5 or 7 because of 5 or 7 in the box. So this must be 2 here, which means this can't be 2. This can't be 2. This is a 5, 7 pair. And this 5 here eliminates 5 here. So this is 7, which makes this 5. This 2 eliminates 2 in the apple here. So therefore, the 2 in the apple has to be here, which makes this 1, which makes this not 1, so that's 2, which eliminates 2 here. We have a 1, 9, 1, 9 pair in this lower central box, which eliminates 1 and 9 in the rest of the box. So this is now 2, 4. This can't be 2 because of 2 in the column. So this is 2 here. This is 4. 4 eliminates 4 here, so it's 6, which makes this 4. We know this can't be 6 anymore, so this has to be 6. Okay. How many 4s do we have? Where's the 4? Actually, we should have a decent amount of 2s also, but not enough? Not enough right now. Okay. 4s. Where's the 4 in column 3? Can't be here because of 4's in the boxes. This is filled. It can't be 4 because of 4 in the row. So 4 has to be 4 there. Where is 4 in this column 4? Has to be one of those two because it can't be here because of 4 in the box. This 4 eliminates 4 from being here, so that's 3, which makes this 4. This 3 eliminates 3 in the column, so now we have a 1, 9 pair in row 9, which eliminates 1 and 9 in the rest of the row. This can't be 9. This is 3, which eliminates 3 here. This is 8 and 9 now. So we had 6s, right? 6s. 6 has to be one of those two. 4s. Where is the 4 remaining in column 7? Can't be here because of 4 in the box, and these are filled out, so it has to be here. So that's 4, which eliminates 4 from being here. So that forces this to be 4, which eliminates the only other possibility for 7 in that row. So this has to be 7 then. And where is 7 in column 4 now? Can't be here because of 7 in the box. Can't be here because of 7's in the row. So that leaves a 7 there. And this has to be 5 because that's the only place for 5 in column 4 now. Remaining digits in column 4 are 8 and 9. This is also 3, 8, or 9 there. Remaining digits in row 4 are 1, 8, and 9. And therefore, we have a 1, 8. We have a 1, 8, 9 triplet in the apples now, which eliminates 1, 8, 9 in the rest of the apples. So this can't be 1, 8, or 9. It's 3. And this one of these 8s has to be in the apple, so this can't be 8 here. So this is 3, which eliminates 3 from being here. That means where is the 3 in the central box? It has to be here. This can't be 3 anymore. This is 1, 8, or 9. 3 has to be one of these two. 8 cannot be 8 here. So therefore, where is the 8 then? In the apples, it has to be here. Remaining digits are 1, 3, 9. This can't be 1 because of 1 in the column. This is 1, 3, or 9. We have 1, 3, 9 remaining in column 3. So this is 3 or 9. This is 3, 8, or 9. It cannot be 3 because of 3 in the box. So this is an 8, 9 pair, which eliminates 8 and 9 in the rest of the row. This can't be 9. That's 3, which eliminates 3 here. So this must be 3 here. Remaining digits in column 1. We have 2 and 9. Okay. Remaining digits in this upper right-hand box. It's 1 and 2. And those can be any of those. Remaining digits in row 5, 1, 8, 9. We have a 1, 8, 9 triplet now in column 9, which eliminates 1, 8, 9 in the rest of the column. So this can't be 1, 8, or 9. We're missing then a 6. So this has to be 6. This can't be 6 anymore. It's 8 or 9. This 6 eliminates 6 being here. So this has to be 6 there. This can't be 1, 8, and 9. It's a 2, 3 pair. And 2 eliminates 2 from being there. So that's 3 and 2. And this has to be 1, 8, or 9 here. This can't be 1 because of 1 in the row. So now let's try to settle these. Okay, so this 8, 9 is different. So we're going to make this red. And then this will make, I guess, blue. Yeah. So blue 8, 9s are here. Blue 8, 9 is here. This is red then because of the stairs. No repeats on stairs. Blue has to be here, so this can't be blue. That's red, which means this can't be red. That's blue, which means this can't be blue. That's red. Therefore, this is red here, so this must be blue here. So blue has to be one of these two, which is fine. Red has to be one of these two, which is fine. What about these? We're going to make this yellow and green. Okay. So therefore, this is the yellow 1, 9. So yellow 1, 9 cannot be here and cannot be here. Well, that means that yellow has to be 1. So we know this is 1. That forces this to be 9 here. So we can remove the yellows and the greens. We know then this is both red and blue, which isn't helpful. 1 eliminates 1 from being here, so that means this can't be 9. This is 1. Blue is here. Red, okay, this is 1, so this can't be 1 here. So this is 9, which means the blues are 8s. So the blues are 8s, the reds are 9s. Okay. That means this can't be 1 or 8. It has to be 9, which means this can't be 9. That's 2 and 9. This 2 eliminates 2 here, so it's 1 and 2, which means this can't be 9, it's 1. And that means this can't be 1, it's 9. This can't be 8 or 9, it's 1. And that's the solution. Interesting. So it uses the apples a lot as a restriction and the stairs a lot. Which is the diagonal rule set. Yeah, it's pretty cool. I'm still confused about the rhyming slang where we have apples and stairs. But I mean, I don't know where what the slang is. I don't know where the rhymes are. I'm just confused. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.